Let's talk about the density of an object. We'll have a couple of examples. One example will be a block of wood right here, and we're given the dimensions of the block of wood. Here's your length, there's our width, and there's our height. And we'll need to know the mass of this. Let's say we put this on an electronic balance and determine that the mass of this, M, is equal to 319 grams. So you need some way to measure that mass, whether it's a triple beam balance or a simple electronic balance. And we need to figure out the density. Well, we got this triangle here. It works really well for the definition. Density is equal to mass divided by volume. And so how do we use this triangle? Well, if I want to find density, and I look at this and here's density, I just cover that over and it says to me take mass divided by volume because mass is on top of volume. What if I want to find volume? So I cover over volume. And then we notice that mass is on top of volume or density. So take mass divided by density. But what if I want to know mass? I cover over mass and it's right next to each other. So density times volume would be what our mass is. Okay, well, let's go ahead and just find density. If I want to find the density, of course, I need to find the volume. And we know if I've got three dimensions, volume is length times width times height. So let's go ahead and do that. So the volume of this would be the length, 15.0. And we multiply that by the width, which is 5.0. And multiply that by the height, which is also 5.0. And that's going to equal 375 centimeters cubed. And we'll write the unit underneath here as centimeters cubed. Now I'm keeping one extra significant digit here because I'm not done with the answer yet. I'm going to, calculate density. And one more time, let me cover this over. Density is covered. Therefore, it should be mass divided by volume. And here's my mass, and there's my volume. So density then would then be 319 grams divided by 375 centimeters cubed. And that's going to come out to be a density of 0.851 grams per centimeter cubed. And notice how our unit, we divide grams, and then over centimeter cubed. And since we're limited to two significant digits, I will eventually round that to 0.85 gram per centimeter cubed. And that's how we handle getting the density of an object if we know its length, width, and height, and of course the mass. Now let's do some liquid here. Let's look at gasoline. Okay, and let's say we already know the density of this. So the density of this liquid is equal to 0.702 gram per centimeter cubed. Now let's look at that a little differently. I don't know how used to centimeter cubes you are, but by definition, 1 centimeter cubed does equal the volume of 1 milliliter. So if you want to think of density of this equals 0.702 grams divided by a milliliter, you can as well. All right, so let's take a look at a couple ways we can do this. Okay, let's say I want to know the mass of gasoline given a specific volume. So let's say my volume is equal to 250 milliliters, and I want to find mass. Okay, I go to my triangle. Let me cover over mass. It's telling me to take density times volume. So mass is going to equal density times volume. So let's go ahead and do that. My mass is going to equal 0.702. And let me times that by 250. Okay, and that's going to equal 176 grams. Now I look at my significant digits. There are 3 in this number. Oh, but that's a placeholder 0, so that's only 2. So I will round to 2 significant digits. There's my first, there's my second. Looking next door, I see I have a 6, which is greater than 5. So I know this is going to be 180 grams. Okay. Now what if I want to find the volume of a specific amount of mass? Okay, so I look at my equation here, my triangle, I cover over volume. Okay, I see that volume is mass divided by density. So volume is equal to mass divided by density. Okay, so let's say my mass is equal to 70.0 grams. And I want to find the volume of that. So let me plug that in. Volume is then going to equal 70.0, and I'm going to divide that by the density, 0.702. Now remember, this is grams per milliliter. So I can then get an answer in milliliters, or I could write my answer in centimeters. Okay, so this is grams here, but my unit here is grams per milliliter. Okay, so we find out that that equals 99.7 milliliters. And if I look at my significant digits, there's 3 here, and there's 3 in this one here. So 99.7, I can keep all 3 digits there. And that's how you handle dealing with density calculations.